The lecture is Urban Futures in Designing the Digitalized City, from Parametric Design to Parametric Urbanism. But before I start, I just need to acknowledge country, and on behalf of those present, acknowledge the traditional owners of the land in which we now meet, and I pay my respects to the elders past, present and emerging. I also pay my respect to all Aboriginal and Torres Strait Islander people from Australia, and hope that their path towards reconciliation continues to be shared and embraced. So critically today, I will give, it's 3/4 Gaudi and 1/4 so what. And what I really want to do is rise to the challenge of talking about how I've moved from parametric design, which is very much object scale to building scale, to parametric urbanism, which is thinking about the city in the same vein. And so in the presentation, I'm going to provide a brief overview of my experiences in pioneering parametric design for architectural scale projects. And I think I can say that I am the first architect globally to understand the opportunities that parametric software offered. And so I'm a genuine pioneer, but not because I came across it and thought that looks interesting. It was because I was at my wit's end trying to tackle the challenge of moving Gaudi's project forward, and therefore looked widely for digital opportunities for assistance. And so we'll refer to that a little bit. I want to argue, though, that parametric design is more than BIM, and that parametric urbanism is more than precinct and city information modeling. The trouble with software is that we are and have been in the hands of the software providers, and the limitations are often set by what the software can and can't do. And as a designer, I recognize the inalienable right of every designer to break whatever tool they're given. It's not in our, we're not engineers. We don't do what we're told. We look beyond whatever we're given, whether it's our gifts or our talents or our tools. And so that's going to be the sort of subplot here. I'm going to be referring to my 37-year-old long contribution to being in the design team on the Sagrada Familia, and I'm going to relate it to a new facility that we've just about to inaugurate in Australia, which is a national urban research platform which brings people to the digitalization of the built environment and vice versa. In other words, we're going to look at the question of how we can design cities more with people rather than simply for them, and seek for new routes for the expert to engage with the end user. And I'm going to ask, what new agency does digitalization and the Internet of Things offer to citizens today? And obviously by asking that question, they'll be asking, what has it got to offer us? So the topics of the day, what is Baukultur? Sorry for my pronunciation, in the digital age. That's a really good one for me because I was taught traditionally. I spent the first 8 years in architectural practice only using rotring pens and slide rules and calculators. And so I have an innate love for the traditional craft of architecture and architectural production, but I'm also fascinated by the digital age we're in, how that relates. I'm going to think about the essence of the digital revolution in respect to the shaping of built environment, and how do we design, build and maintain the built environments based on craftsmanship, data and algorithms. So these are all what I've been given to talk about, but it's exactly what I like to talk about. And the take-home points will be the disruptive aspects of digital processes, data-driven decisions, parametric architecture, parametric urbanism, and generative design. So I can't give you the whole history of the project, nor can I explain my design experimentation because I don't have the time to do that. So I'm going to try and condense my learnings from being involved in this great project for most of my professional life. My involvement ceased in 2017 when I've completed the schematic design with the team for the Glory facade, which is the main facade. That's the last design challenge that Gaudi left us, and so I was able to hang up my T-square and move on to other things. But I've seen the project go from virtually nothing to completed inside at least, and well on the way to being completed on the outside. When Gaudi died, he just left the 4 towers almost completed. That tower there, I'm assuming you can see my mouse. Somebody shout if they're not. But that tower on the left was actually the only tower that Gaudi saw completed when he died in 1926. And the other 3 were still in scaffolding. And a bit of the walls around here, about 3/4 of the apse, had been built to this height. And when I joined the project, a second group of towers had been added. So I've seen it go from just almost the minimum to, as I say, a completed interior, which is what this looks like. Now, Gaudi is just as so much soul. It's difficult to find another architect who really could embrace every aspect of the architect's craft, whether it's the engineering or the artistry or the volume or the light. It just seems to be the master of it all. This is the interior that he never saw. He modeled it up to the scale of 1 to 10, but he never saw it like this. And as Gunther mentioned, my role was really to take fragments of plaster model at a scale of 1 to 10 and 1 to 25 that survived from shattered models for this interior and help understand what the geometry was that he started to use. The remarkable thing about Gaudi is that he went from being a sculptor, having difficulty meeting the challenges of an architect's production. So many of his projects are actually regrettably unfinished, and the Sagrada Familia being one of them. But he in his later years, he realized that he couldn't proceed as a sculptor and leave a project unfinished like the Sagrada Familia without some kind of plan for others to follow. And so he embraced second order geometries, particularly doubly ruled surfaces. So that every surface that you can see here, although they look as abstract as anything he might have done in his early career, in fact, is definable geometrically. It means that you can take parts of the broken model and pull from it the geometry that he was using. So when I worked on the project, initially I was working using a very large table and projecting in 3 dimensions with a slide rule for calculations and rotating pens and pencils to try and understand this geometry. And it was just as computers were beginning to come of age at a technical level in terms of laboratories, but also in 1979, when I joined the project, the first whiffs of home computing was starting. But obviously the problem that Gaudi left for his successors was far greater than those early pioneering home computing. But in fact, even 10 years later, when software started appearing for architectural practices, none of it was appropriate for the Sagrada Familia. And that was why I was forced to look beyond architectural software to aeronautical engineers and boat builders. And surely, as it turned out, they had software which would start looking at these complex geometries. And that's how I found parametric design in 1992. 15 years minimum before it really became a tool for architects to play with. But I couldn't believe it when I came across it, that you could design complicated things and then experiment with the values that were behind the underlying geometries and get a reversioning happening within minutes rather than days. So this is the interior. It's designed for 7,000 people. This is on the inauguration with the Pope in 2010. So it's now been a completed interior for 11 years. And until the ravages of the pandemic, it was on target to be completed on the outside in 2026 to celebrate Gaudi's his death, but it'll be a bit late, unfortunately. So the things I really wanted to labour were what were the discoveries along the way. I've mentioned the fact that Gaudí, this genius, in fact, decided to elevate his work to the geometer and bring geometry in. But this model, which was a 3D print of 2012, that was the earliest we could actually produce a version in 3D of the project that we were working on. So for instance, I was very involved with the production of this space here, which is at the base of the main tower. This tower is 172.5 meters tall when it's finished, and at a height of 75 to 85 meters, there's this room called the Cellar Cloud. And I'm going to talk about that in detail because I think it brings everything together. But the remarkable thing is that the design of this space had to occur before we could ever see it as a model, because we didn't have the data that would allow us to make a 3D model of the existing Gaudí fragments. LiDAR scanning, which of course we can even get it on our phones and tablets and iPads now, was not even available till 2008. In a usable form, which is when we were able to start scanning the outside of the building and capture the data. So I'm not sure the age of the audience, but for anybody who's in their 20s, this stuff that probably seems just familiar now, I find it remarkable that 12 to 15 years ago just wasn't available. And 3D printing has only been around for 20 years. So you can imagine how pleased we were in 2012 to finally have a whole model of the building and in 3D that would allow us to look at the main facade, which you can just see in this little image here, in the context of the whole building. Now the Cellar Cloud is here, and whereas for all the work that we were undertaking for the nave and the main interior of the Sagrada Familia, whereas we did have these fragments of models and drawings with this level of detail by Gaudí himself, what we didn't have was information for this area. Now, getting to the top of the building is very important. It'll be the tallest religious building in the world. It'll even be higher than Ulm Cathedral, which is one of the highest in Strasbourg. As I said, it's 172.5 meters high. And everybody going to that cross at the top will have to go through this area here. So the debate was, what on earth was Gaudí thinking for the apse? Because, sorry, for the Cellar Cloud, because did he leave it undetailed like the lower part because attics weren't important to him? Or was it so far away from the critical challenge of getting the worshipping space finished that it was just one thing too much? So this led to quite a debate in the office between the pragmatists who just said this is a service space and we should save money by not going too overboard on it, to others, including myself, was saying that, but look at every single Gaudí attic space and loft space. Not one of them are unresolved. They're all remarkable. So the decision was that this ought to be some kind of meeting point, and the contours that Gaudí fortunately left from the vaults below suggested some kind of auditorium space. So the initial ideas was to produce a floating, an auditorium sort of stuck at the bottom of the tower. And this evolved from being like the end of the base of the tower to something a little bit more sophisticated. In other words, a floating auditorium that would allow light come in from above, and also light would get in beneath it and down through those vaults of the ceiling that we looked before. And this, as you can see from comparing it with the original Gaudí, there's a big difference. And this is where we are now absolutely exposed to any criticism that you might want to throw about, but this isn't what Gaudí wanted, because all we know what Gaudí wanted was that. But we did feel duty bound, obviously, to employ the learning that we got from working for the apprenticeship of 20 years of computational design with the lower part, resolving Gaudí's design, to thinking about how we would tackle this area above using these geometries and principles that he gifted us. And I didn't realize at the time, this is about 2005, I thought, well, since we're using all this aeronautical software, and aeronautical software is absolutely set out as a kind of BIM, it's for planes. For decades, they've been sharing models and working together collaboratively. And we were using CATIA at the time, which is from the aircraft industry. So it just seemed natural that we would work in 3D with a shared model. And I found when I started doing my research that there was just no practice that I was able to come across in the world, architectural practice that was actually sharing models. They were sharing data and sharing drawings, which are abstractions, but not sharing the models. So we were able to use this project as a prototype for looking at parametric design and the shared model for collaborative design. So I don't know how many of the audience are into this, but let me assure you that if you're not working in a shared 3D or 4D environment yet, it's something I would suggest you look at very seriously, because it is a real game changer in terms of what can be done in the hours you've got, but also the sheer richness of being able to share spatial information across. So you're looking at a Rhino model on the left-hand side, which is the model environment we use for translating. When I say we, I'm talking about my team. It's not across the whole of the Sagrada Familia team by any means, but Rhino is. But our use of Rhino was at the end of the journey. At the beginning of the journey, we always started with a sketch, a hand-drawn sketch, from which we would derive the parameters, and the parameters would then become the components of each of this. So what you're looking at here is each of these lines represents, if you opened it up by pressing the plus sign, you would have somebody else's model working in the space. And the other thing that we thought about a lot, because I was always, whenever I was in an interview of television or radio, someone would always ask, but, you know, what do you think Gaudí would have done with the computer? And I just have to say, no idea. He embraced technology when he had to, but he was famous for saying that innovation should be in the design, not the construction. You know, be experimental in the design, but in construction, there's a lot at stake. If you experiment with construction and your building's got a 1,000-year design life, how can you be sure that you're not going to fail in any way? So we've always taken that on board. We've used traditional techniques where possible, but in certain parts of the building, it's quite clear that unless you use reinforced concrete and some very sophisticated engineering that Arup have brought to the resolution of the main towers, there wouldn't have been any prospect of finishing the project as Gaudí had intended. But whereas he was constrained by hand modeling processes, and you can see that these are the hyperbolic geometries that I'm referring to. Normally I would love talking about this at length, but these are hyperboloids of revolution of one sheet, and they're characterized, I've got a faulty mouse here, they're characterized by any point on the surface having two straight lines lying on the surface, which means that they're very easy to describe if you're trying to make them, and they're very easy to describe if you're making a plaster model. Obviously with robots today, that's not an issue, but one question I'd leave with you, just because you don't need to have an underlying principle of a geometry, for instance, acting as the kind of compositional language, does that mean if you don't need it, you don't have it? I would make an argument that if you have geometry as a compositional language, it means you can have a conversation across others as architects. Whereas if you're using free form, the sculptor can only talk to themselves. So in this case, if you look on the right-hand side, you can see that these windows, whereas Gaudí had to build his geometry against a reference plane, in other words, a flat surface, we don't need that. So we can still work with these geometries, but also we can bring a kind of Baroque dimension to this. And so these windows are actually have a curvature to them that Gaudí wouldn't have been able to have brought in his analog method. So my answer to the question about what would Gaudí do with the computers, I would say he would do as little as possible, but he would do the things that weren't possible with his analog techniques. And this is an example of that. On the left-hand side, you can see another very important image, which I think calls to question the way we produce buildings worldwide. The fact that we have our consultants as separate businesses and the client and the builder are all separate from each other. What's remarkable about the Sagrada Familia is you learn what happens when the client, the builder, the architects, the engineers, the cost consultants are all in the same team. It means that there isn't any preciousness. You won't get any architect on the project saying that they are the architect for the building. They'll say that they're working on the team with the team that's completing Gaudi's project. So here you can see an engineer, Carlos Bouchardé, and a colleague from the architect's office looking at the resolution of the structural arrangement for this space that we're looking at. And there's no prissiness. We were using rapid prototyping. In those days it was wax before we had the 3D printing of today. We had bits of model that were even from Gaudi's time. We're using provisional pieces of aluminium tubing and cardboard to make decisions. And I just think that that image, when I was asked what was the image that one image I could sum up the experience of working at the Sagrada Familia, that is the experience. And I wish that everybody in the world could find a way to do projects with that kind of spirit. The plaster model makers would take months to build the models, and they certainly couldn't make models quickly at the scale you can see on this image on the right. Here you can see 3 versions that were printed in the plaster model maker's office, which is where we're meeting in the left, by the way. All the decisions seem to be made in the model room, not in the drawing office. And so it was fantastic getting an opportunity to start doing design at a very rich level at the speed that we needed to do it, rather than having to take shortcuts or rule things out. And you can see the resolution of the design through this process of 3D printing. That's at a scale of 1 to 100. So here you can see the final resolution of the design. It's that is what's being built, which I'm going to show you now. You can see here that light can get in through to these vaults and down to the interior, and obviously the space above. But here's the thing. You know that the worst line you can ever say to anyone is, the worst answer you can give when somebody says, "Are you sure that it will work?" And you say, "Trust me." Well, the question that was being asked repeatedly was, "Are you sure there'll be enough light in here?" And I'd be saying, "Well, trust us." But it was actually very difficult to predict because this is what I call an unfamiliar space. And one of my research projects at the present is called Visualizing the Unfamiliar. Because what we've discovered is that if you're doing a space like this, you can use all the VR you like, but it does not give a facsimile of the space, because the person who's actually experiencing the VR or the AR experience isn't able to relate it to something that they've already seen. So it's all right for us because we're familiar with the geometries, but if you're not, and as a result of that, we had a lot of difficulty. I'll show you some images in a minute, getting a sense of what it would be like. So this is the funny thing. We end up actually having to model at a ludicrous scale to actually get some real sense of what it's going to be like. This isn't the Cellar Cloud. This is the Glory facade, looking at an option for one of the rose windows in the middle. But I just love the fact that even with all this wonderful visualization, which it's a large part of my job, we still have this challenge for unfamiliar spaces to get a real sense of the likely experience. So here's we made a model at 1 to 25, which we use for exhibition. And you can see in this one how we have embraced all of the lessons that we learned from Gaudi's treatment of the interior below, so that that's what you're looking at from the ground floor up at the base of the Cellar Cloud, and then we've got a ceiling which we have drawn from the lessons from that. So there you can see the auditorium, and you can get into it from these towers here, and you either enter it below on a glass walkway, which is snaking around beneath the auditorium, or you come at a higher level and you can come down and find a place. So the idea is that if you're going up to the main tower on the top, you can only have 17 people up there at once. So you take your turn, and this will probably be an experience center where you can study more about the building while you're there. So that's the model. So these are the images. As you can see, these were done by Australia's best renderer, and they're not really working for us, are they? If we look at them in detail, you can see that the details where with familiar materials, they're absolutely perfect, stainless steel and glass. But trying to get a treatment to the surfaces such that we could say, trust me, it's going to be okay, and have a credible piece of evidence, it didn't work. So we had to wait until the scaffolding came away. So I don't want to dwell on this, it's becoming more familiar, but while we were doing this, not only have we pioneered in the use of 3D printing, we were the first architectural project, obviously, to use parametric design, but then the 3D printing as well. Then off-site fabrication, absolutely the sort of world leaders in this in the 2000s, where by the time we got to this point, after this concrete pouring for the auditorium, everything else was made off-site and brought to it. So you can see all the precast elements sitting here on the bottom left as the project goes up. And then at this bit, you can just see in the bottom right-hand image, that's actually getting ready for being made by hand. So elements of the project are still done by hand where possible, and where it's expedient, they're made off-site as prefabricated units and brought. So here you can see the hand making part, and that's the shuttering for artificial stone. And because we're using this engineering software, we were able to optimize with the parametric model so that the skin for the roof of the Cellar Cloud, the space I'm showing you, we could actually set it with an optimization algorithm that came with the software, that no part would be less than 15 centimeters thick and no part would be 20 centimeters thick. So instead of having to explore different geometries till we got the right answer, we could just put the values for the geometry, the geometrical variables in, and play it until we got the right answer. And so it's an incredibly thin skin. So when you look at that, if you're on site there and you're looking at the base for the tower, you're looking at a very, very thin skin holding it up. And here you can see where a robot cut stone on the outside of the building meets artificial stone that's been made off-site. And when I've had people standing with me next to it, and I'll say, actually, one of this is artificial stone and one is concrete. Sorry, one is real stone. And they'll say, yes, yeah, I can see there's a slight difference. But when I ask them which is which, they don't get it. So you will read from time to time what a pity it is that the architects have adopted artificial stone or concrete for some of these surfaces. But I can assure you that it's not a decision made lightly. We use a large number of aggregates and cement to get exactly the same chemical composition as the sandstone that it's imitating. And here you can see the off-site. So even these very thin stone shells are made off-site and brought on-site. And here it is under construction. And as you can see, we could be trusted. It is perfectly light inside. It's actually a very beautiful space indeed. So I just want to finish up by bringing this all to today, and what does it all mean? So last year I had the privilege of assembling a large number of very thoughtful and imaginative, creative people to look at urban futures as an issue of AD. I'm designing the digitalized city. And it's in 3 parts. It has a sort of historical take on data. So what I've just been spending all the time talking about is condensed to a very small part to say that we've always had data. We've always had architects who've realized that geometry is a very good underlying principle for design. The middle part is looking at how we look at the visualization of data and imagine the future, and how we pull out of data the unknown. And then the last part is thinking about where are we going and what are we going to do with it. And it was a very timely issue. As you can see here, there's some great people in there. As the list there, but Revik Anadol, I'm sure you don't need any introduction to him, employs AI and visualization and casts it onto buildings, most memorably the concert hall at Disney. But at the moment in Melbourne, he has a 10 meter by 10 meter installation. I looked at it on site yesterday. I've seen the real thing. It's just amazing. But I have to say, if you go to his site, you'll be amazed. So a lot of these are like Ed Parham's from spatial syntax in London, and is deep data mining with a view to design emerging from data. And Wayne Hay is the founder of XCool, who does extraordinary things. We'll have a quick look in the remaining few minutes that I have. So in the issue, I make a case for making it that it's better to make a good future than predict a bad one. And that's what designers should be doing, is not reveling in self-pity or worries or neglect or whatever, but actually think about what we have to do to make a better future. And that is the spirit of the issue. And I look at things like Valencia. This is an image from 1853 of Valencia, a sort of bird's eye view. And those of you who know Valencia will be surprised today, will be surprised to see a river in this picture, because they made a far-sighted decision after disastrous floods over history to actually divert the river away from the city. And the river has now become this extraordinary park. In Melbourne, the point being that we need to be visionary, and nothing's too big, so even a river can be diverted. I also draw attention to people who were way ahead of their time. This is Ernst Fuchs, who is from Austria and came to Australia as an emigre from the Second World War. And he was an urbanist as well as a great architect. And he produced this book as a call to arms called X-Ray of the City, and was arguing that in 1946 that Melbourne was growing so quickly that it needed the skills of the radiographer to understand what was happening at a level of data in order to think about how to make sure that the city would evolve into one where nobody would be more than 20 minutes from where they worked, where they lived, and where they entertained themselves. And that's a far cry from Melbourne today. Melbourne's an extraordinarily large city. It's at least 60 kilometers in one direction of just suburban sprawl. It's a very livable city. It's always in the top, 3, well, not always, but it has been for years in the top 3, along with Vienna, which we were talking about before. Yet it has got this awful sprawl that needn't have happened. And it's radial, so a lot of people have had to come to the CBD for work. And of course, the current pandemic has called that into play. So when I'm talking about sprawl, this is what I'm railing against. In the bottom part of the image, you're looking at the market gardens, which currently feed Melbourne. And on the top half of the image, you're looking at these suburbs. There's no civitas to them. There's no urban design that makes you feel that if you landed in a parachute, you'd know exactly where you were. You wouldn't. You could be anywhere in this enormous place. And you can see it's just packing as many houses into as small an area as possible. And where there's sort of inconvenient bits of geography like a river, then they'll make some effort to involve it. And yet other cities like Singapore has an urban experience in the city gallery. And I don't know how many of you are in cities which have these, but I feel that where I live, we're desperate for such a facility. It's basically a museum that looks at the future rather than at the past. and people can interact with the displays and get a sense of what's at stake. And so I think this is really what I'm going to be finishing up on is what is it that we as designers will do with the digital tools we have to help our clients, whether it's at the house level or the institution level or the city level. What are we going to do with these wonderful tools to give the client a better understanding of what's at stake? Not here's the solution, but what's at stake, and how can we use these tools together to come up with an answer? And we've got some dark forces in front of us. This is an example from Weston Williams and partners, which is looking at these polycentric cities where you won't be far from anywhere, and you can connect between centres through high-speed rail. And the innovation that I alluded to at the beginning that we're about to launch is a remarkable new software which is open source, which allows everybody with a device to put a high resolution version of it up on the screen. So these people around the table, you can see here, whether they're using a laptop or a phone or a tablet, they can put their material up on the screen. And so I think this is one of the ways forward, is that architects and experts, along with the end users who are the citizens and the dwellers, will be able to have a conversation in a new way where the visual language is the common language. We're not relying on PowerPoints and whose turn it is to have the projector, but we can actually show our work together and start working the way that architects have always worked, which is across images to compare and contrast. So that's what that's my exciting piece of news. That's what I'll be devoting my energies in the future. And I can just play this video, I hope, which is designed to share the excitement. I hope it's playing. This is a hold it video because we couldn't get into the building, because although it was finished in August last year, we've been banned from going to campus. But here you can see the dimensions of the problems that we're tackling in Australia, at least. And that technology is also going to be an amazing portal to collaborations across other cities in Australia, as you can see. I'm going to wrap up now because we are at least some time for questions, but I just wanted to give you an insight into the journal. We've got work as diverse as Tom Kavan, who's looking at calling for a theory of data-informed design, that it's more than just looking at the data. We need an actual theory that we can work with. And Justina Karakovic is looking at complex adaptive systems. So I think this is a very interesting take that will help protect us from some of the darker sides of AI, where you actually have an aspect of adaptability in the design process, that you don't set it all out at once, but you actually map everything so that change can be absorbed as it might. And then Ed Parham, who I've already mentioned, from Space Syntax, he's written about the unknown unknowns. This is a fantastic territory for us to be getting involved in as designers. It was always about working with known unknowns before, but with big data and the computational power and the AI algorithms that are emerging, we can start getting insights that we wouldn't ever have got for ourselves. And then finally, this is Wan Yu He, who is looking at AI to generate design. So she has used Google Street View and captured through AI all the images for a neighborhood, and then using AI has actually built a vocabulary of features and then constructed possible architectures. Now, I think this is teetering to the unacceptable edge of AI. And one of the topics I was going to talk today was about generative design. And so my last word on that is, let's be careful. So just to sum up before some questions, really the take-home points about, I've shown you digital processes, data-driven decisions, parametric architecture, all from Gaudi, from someone who died in 1926. So I hope that's given you even more confidence in taking data and the digital seriously. Then explained how we are at the cusp. It's really only beginning with the computational power, the LiDAR scanning, the drones, and the data sensors. Parametric urbanism is really going to come out very much, I think, as a great opportunity for architects. And generative design, I argue that if you rely on generative design through your algorithms, it's for the bankrupt, the creatively bankrupt. You should use generative design to support what you can already do, but not as a replacement. So I would argue that all these things are exciting augmentations to human creativity at the building to urban scale, and not something to lay awake worrying about each night. Thank you very much.